Hey guys, what's up? क्या चल रहा है guys? अच्छा मेरी बात सुनो. I'm going to be solving some questions related to kinematics, dynamics, and some energy level questions because energy तो हमेशा ही आता है हर चीज में. Anyways, I'm going to be beginning with the questions and I'm going to be solving these questions. So let's just see how it all goes together. I think I have a calculator with me and both of these are working okay-ish, but I'm going to be working these questions out. Anyways, let's just begin. अच्छा सबसे पहले question reads, I'm just going to be zooming out a bit so that it becomes easier on the eye. अच्छा ये हमारे पास कह रहा है a ball is thrown from a point P with an initial velocity u of 12 meter per second at 50 degrees to the horizontal as illustrated in figure 2.1. Okay. So apparently we have a stone that is thrown at 12 meter per second at an angle of 50 degrees. We can see that Q is a point where the ball reaches a maximum height. Air resistance is considered negligible. So there you have it. Calculate the horizontal component of U, where horizontal component is the easiest part, and that is going to be this component over here, which is going to be, I'm just going to be writing this down. So the horizontal component of U is going to be 50 cos, oh my God, 12 cos 50 degrees. If this is 12 cos 50 degrees, so this is going to become 12 cos 50 bracket closed, and this gives me a value of 7.7. First of all, let me just look at the precision that we have to maintain. Two significant figure is more than enough in this case. So 7.7 meter per second. Okay, so this is it. Next step, the vertical component of U. Our target is to find the vertical component, and that is even way simpler. This is going to be 12 sine 50 degrees. Sine 50 degrees. So this is going to be, let's just find it out, 12 sine 50 degrees, and this value is coming as 9.2 meter per second. Okay, so this is going to be 9.2. This is done. Let's just move on to the next question. Show that the maximum height reached by the ball is actually 4.3. Assuming air resistance is completely wiped out, not there, negligible. So we need to find the maximum height reached. The maximum height is actually going to be this height over here. अगर ये निकालनी है तो इसके लिए हम लोग एक काम करते हैं, equation of motion लगाते हैं, ऊपर जाते हुए slow down हो रहा होगा. So we are just going to be using some equation of motion that is going to find this height. So let's see. The final velocity at the top is always 0. That is something we have. So V is equal to 0 meter per second. The initial vertical velocity is actually 9.2 meter per second. We have the acceleration due to gravity, which is minus 9.81 meter per second squared. नेगेटिव इसलिए लिया है बिकॉज ऊपर जा रहा होगा तो स्लो डाउन हो रहा होगा. तो इसका मतलब है कि फाइनली v square is equal to u square plus 2as is just going to cut it for us. And let's just scroll down a little bit and let's see. भाई v square जो है वो पहले हमें पता है फाइनल वेलोसिटी 0 है, तो इसका मतलब 0 स्क्वायर इनिशियल कितना है 9.2 है, स्क्वायर है प्लस 2 टाइम्स acceleration is minus 9.81 and s is the height that we need to find out. So कैलकुलेटर में डालेंगे ऑटोमेटिकली पॉजिटिव आ जाएगा. 9.2 का स्क्वायर डिवाइडेड बाय ब्रैकेट्स में 2 multiplied by 9.81 and that gives me a value of, I hope मैंने स्क्वायर किया था, s is equal to 4.3 meters. Proved हो गया भाई ये. This is proved. Let's move on to the next part. Determine the magnitude of the displacement PQ. Okay, PQ कहां पर है? Let's just look at this diagram first. So the magnitude of the displacement PQ, we need to find this magnitude over here. So we already have this. This is actually 4.3. अब मुझे जो है ट्राइंगल कंप्लीट करने के लिए जो नीचे वाला जो हॉरिजॉन्टल डिस्टेंस है, आई नीड टू फाइंड दैट आउट एंड आफ्टर दैट आई कैन इजीली फाइंड आउट. सो पहले तो हमें ये निकालना पड़ेगा. So we already have the speed over here. The horizontal component of u is actually 7.7. लेकिन अभी इसके लिए हमें बहुत सारी मेहनत करनी पड़ेगी. We need to find the time taken for the ball to reach this position, and this time is going to be common for the two movements over here. Let me just do it for you guys. Okay, guys, अब इसको करने के लिए सबसे पहले तो हमें टाइम निकालना पड़ेगा. अब टाइम के लिए we need to just scroll down a little bit. First of all, let's find it's a 4-mark question. That is why itna complicated. Complicated to nahi, it just requires a lot of work. So first of all, let's find the time. ऊपर जाने का टाइम पहले निकाल लेते हैं. We already have V, U and A. So इसका मतलब है कि V is equal to U plus AT लगा दें. So V is equal to U plus AT to find the time taken to reach the maximum height. So final velocity is actually U. Initial velocity is 9.2. Acceleration is taken as minus 9.81. And let's just find this time T. अगर ये time T निकालेंगे तो ये आ जाएगा 9.2 divided by 9.81. And this gives me a value of 0.94. Time is equal to 0.94. तो सबसे पहले हम लोग horizontal distance निकाल लेते हैं. So therefore, I'm just going to be writing it down. So horizontal distance is going to be speed into time, which is 7.7 multiplied by 0.94. Be careful, ये वाला जो है, ये वाला horizontal component था, तो horizontal component क्योंकि horizontal distance निकाल रहे हैं ना, तो जो भी time आया है, इसको हम लोग जो है एक काम करेंगे, multiplied by 7.7 कर देते हैं, and this I'm getting a value of 7.2 meters. ये आ गया. अच्छा, इसका मतलब है कि जो हमारा ट्राइंगल बना है वो कुछ इस तरीके से था. This was P, this was Q, and this distance is 7.2 meters, और जो हमारा maximum height थी was actually 4.3. So let's just use Pythagoras theorem. तो Pythagoras theorem use करेंगे हम लोग, तो ये हो जाएगा 7.2 का square plus 4.3 का square, and this should be equal to PQ का whole square. So ये हो जाएगा 7.2 का square plus 4.3 का square, and finally applying the root operation, this just gives me a value of 8.4. So PQ is actually 8.4 meters. PQ भी आ गया, so this is actually 8.4. Anyways, this is done. Simple था. Let's just move on to the next question and see where the journey takes us. Okay. A ball of mass 150 gram, be careful, it is given in grams, is at rest on a horizontal floor as shown in figure 3.1. यार ये जो मैं questions करा रहा हूँ ना, यही कर लो, बहुत है, more than enough है for you to actually clear your paper with an A. Anyways, I'm just going to be helping you out. आप लोगों का तो देर में है, लेकिन A2 वालों को तो बहुत जल्दी है, so उनके लिए भी काम करना है मुझे. Anyways, guys, a ball of mass 150 gram is at rest on a horizontal floor as shown in figure 3.1. Calculate the magnitude of the normal contact force from the floor acting on the ball. अगर ये stationary है, जो normal contact force होगी वो weight के बराबर ही होगी. वरना अगर if it were not true, if the weight was actually greater than the contact force, the ball would simply go inside the floor, which is not true. Anyways, so normal contact force must be equal to weight in this case. Not all the time, but abhi hai. But that does not form a Newton's third law pair. Be careful, only contact forces form a Newton's third law pair. This is not a Newton's third law pair, but the condition needs to be satisfied for this question. अगर नहीं समझ में आया तो you need to attend my classes. Physical classes में वो कराता हूँ, लेकिन अब तो खैर time भी नहीं है. You just have this. Whatever I'm doing, सीख लो, रट लो, पेपर जाके देकर आ जाओ. Anyways, so normal contact force is equal to weight, which is actually equal to 150 divided by 1000, because I need to this in kg and multiply by 9.81. ये तो पता होगा ना 9.81 क्यों है. खैर 150 divided by 1000 multiplied by 9.81. And this gives me a value of, the force is roughly equal to, let's see, 2 significant figure is more than enough, so I'm just going to round it off to 1.5 Newton. ये तो हो गया. Explain your working in one. Well, the explanation is that since the ball at rest, weight must be equal to the normal contact force. But please mind you, we will not mention Newton's third law because this is not the consequence of the Newton's third law. Just be careful. अच्छा फिर ये हमारे पास कह रहा है the ball is now tilted above the floor, lifted above the floor. Okay, I'm so sorry, and dropped. Okay, so we apparently have to drop things so that it falls vertically as illustrated in figure 3.2. ये बॉल गिरी नीचे, रेस्ट से इसको ड्रॉप किया. ड्रॉप का मतलब ये है कि दैट it was at rest initially and then you just let go of the ball and it just simply falls down. Okay, after impact something happens to the velocity over here which has actually changed direction. Just before the contact with the floor, the ball has a velocity this. The ball bounces from the floor, and just after losing contact with the floor is this. The ball is in contact with the floor for this. Okay, ये हमारे पास information है. State Newton's second law of motion. यार ये वाला जो law है ना, for some odd reason you guys are still stuck in the world of O levels. यार grow up. इस तरह लिखो, force is equal to the rate of change of momentum. Ye लिख कर आना. Please just write this down in the examination. Do not change the definition. Okay, now we need to find the average resultant force on the ball when it is in contact with the floor. So average force must be equal to change in momentum. P stands for the momentum over here over the change in time. So the change in momentum is going to be mass kitna tha iska 150 grams tha, I guess. So that is going to be 0.150 multiplied by the change in velocity. अब हमारे पास ऊपर जाते हुए जो है इसको नेगेटिव लें या पॉजिटिव लें, इट्स टोटली अप टू यू. आई एम जस्ट गोइंग टू कीप इट एज पॉजिटिव एंड नीचे को नेगेटिव ले लेते हैं. सो दिस इज गोइंग टू बिकम 2.5. सो ओ माय गॉड 2.5 माइनस ब्रैकेट्स में बिकॉज दिस इज अ चेंज इन वेलोसिटी, बट देन अगेन मेरे पास ऊपर जाते हुए पॉजिटिव था and when it was actually just falling down the velocity was taken as negative, so this is going to be minus 6.2. So that should do it. And then divided by 2. I mean divided by the time taken for the contact, and that time was actually given to us as 0.12 seconds. Okay, 0.12 seconds. Oh my god, 0.12 tha ya milliseconds tha na, it was actually in seconds. So that does it, that does it, that does it, that does it. 0.150 multiplied by 2.5 brackets mein. My god, 2.5 plus 6.2 bracket closed divided by 0.12, and this gives me a value of magnitude of the force is actually 10 point let's just round it out to three significant figure, 10.9 newtons. Direction of the force on the ball is actually upwards. Okay, state and explain whether linear momentum is conserved during the collision of the ball with the floor. It is always conserved. Always conserved. Always conserved. In a closed system. Isolated system. Isolated का इधर मतलब है इधर ही लिख लेते हैं no air resistance. सही है. अब मुझे प्रूव भी करना है whether linear momentum is conserved during the collision of the ball with the floor. So the change in momentum of ball is equal to and opposite to the change in momentum of floor. This is done. Okay, question. Let's just move on to the next question. Let's see. Explain what is meant by gravitational potential energy and by kinetic energy. Oh my god. ये वाला जो होगा gravitational potential energy associated with the position of an object with respect to the ground. Okay. Energy associated with the position of an object with reference ground. Oh my god. Kinetic energy. Energy associated with the motion of an object must be moving. Okay, ये भी हो गया. Next step. A motion sensor is used to measure the velocity of a ball falling vertically towards the ground as illustrated in figure 3.21. Okay, there are motion sensors here. We need motion sensors at our house because you never know. We live in a country where we live in a city where every day something bad happens. So motion sensor is important as well as night IR. And if you see some activity, what can you even do about that activity? That is a big question. जब अगर नजर भी आ गया तो फिर क्या करेंगे? कुछ नहीं. Lock the doors, throw away the key, and sleep well. This is what we have to do. Nothing to laugh about, but then again, it is something serious. We need to think about our own security, so let's just work this out. A motion sensor is used to measure the velocity of a ball falling vertically towards the ground as illustrated in figure 3.1. The ball passes through points A and B as it falls. Obviously, this must be accelerating. The ball passes through whatever. The ball has a mass of 1.5 kg. Okay. Next step. The variation with time t of the velocity v of the ball as it falls from A to B is shown in figure 3.2. Okay. Ball at position A and the ball at position B. We can clearly see that something has happened. The velocity has actually increased between the 2 points. We had less velocity, more velocity. तो velocity में change आया तो इसका मतलब है that means there must be some acceleration. Okay. Constant acceleration. यानी resultant force भी होगी. Next step. Let's just scroll down. Use this figure to calculate for the ball falling from A to B the displacement. Falling from A to B, the displacement. Displacement is simply the area under the graph. So we just need to find the area under the graph. Be careful, this is a false origin case over here, लेकिन area under the graph के लिए हमें जो है पूरा का पूरा लेना पड़ेगा. So just be careful. It is just going to be a trapezium, but be careful, this is a false origin case. So first of all, the displacement is going to be from A to B, the displacement is going to be area of trapezium. So area is actually going to be half into height. The height is easy. This is going to be the height. And that is going to be 0.4. 0.4 multiplied by the sum of parallel sides. Parallel sides में एक value ये ले लेते हैं, which is actually going to be 7.8. Okay. फिर उसके बाद जो है 4.9, 3.9 plus 3.9. So this is going to be it. Be careful, मैंने subtraction नहीं की इधर, just be careful. So false origin से लिया हुआ है तो 0.5 multiplied by 0.4 multiplied by brackets में आ रहा है 7.8 plus 3.9 and this gives me a value of 2.34. The displacement is actually 2.34 meters इसको मैं पहले कॉपी कर लूं, इधर ले आते हैं. But first of all, I just need to see कि मेरे पास सब two significant figure है, so we can always increase one significant figure more, so that makes sense. Now we need to find the acceleration. For the acceleration, we'll just resort to finding the gradient. So gradient. So for gradient, I'm going to be zooming out, scrolling up. नजर तो मुझे कुछ भी नहीं आ रहा, so I need to zoom in again. So let this coordinate be 0.8, comma. The vertical axis coordinate is actually 7.8. Similarly, this is actually going to be 0.4, comma, and this coordinate is 3.9. Sorry, 3.9, yeah. 3.9. Sahi hai. So the gradient is actually equal to, m is equal to, which is the gradient, 7.8 minus 3.9 divided by brackets x2 minus x1. So 0.8 minus 0.4, bracket closed, and 9.75. So 9.75 meter per second squared. This is the gradient. So you have to show this working in the examination, but मैंने ऐसे directly कर लिया. So this is actually 9.75 meter per second squared. So this is actually equal to the gradient. Anyways, this is done. Next step. The change in kinetic energy. Okay. So we had one speed, we had less speed initially, we had more speed finally. So that means final speed minus the initial speed plus squared multiplied by half m. So iska matlab hai the change in kinetic energy, change in EK should be equal to half m. M is common. So let this be V final squared minus V initial squared. Direct answer aa jayega. So half into the mass, पता नहीं कितना था इसका. Yeah, this scrolling kills me. 1.5. So ये हो जाएगा 1.5 multiplied by V final. I think 7.8 था. The change in kinetic energy from A to B. Okay. So B पर है 7.8. So this is actually 7.8 का square minus. Oh, 3.8 था, कितना था? 3.9 था, 3.9, 3.9. So this is actually 3.9 squared. Acha, remember this thing, if you square this over here, then you need to go and study O-level mathematics. Don't do that. So 0.5 multiplied by 1.5 multiplied by brackets, 7.8 squared minus 3.9 squared, bracket closed. And the value is actually change in kinetic energy is roughly given or give or take 34 joules. Okay, ye wala bhi. Show that the work done by the gravitational field on the ball in B as it moves from A to B is equal to the change in kinetic energy. So we need to find the work done by the gravitational field. We need to show that. अब इसको हम लोग कैसे करेंगे? MGH, we can find the height. We definitely can. So let's see. So change in GPE is actually equal to work done, which is equal to force into distance. Force हम लोग निकाल लेंगे, mass into acceleration. So this is going to be mass into acceleration multiplied by the distance. Distance, I think हमारे पास A to B तो हमने पहले ही निकाल लिया था. I think the displacement was actually 2.34, so I'm just going to be using that. So this is going to be 2.34. The mass is 1.5. Multiplied by the acceleration, we already found the acceleration, which is 9.75. Let's do this calculation. Fingers crossed, दुआ करो कि सही आए. सही आना चाहिए. Same आना चाहिए. 9.75 multiplied by 2.34. Yay! Same answer aa raha hai. So this is actually equal to 34 joules. Prove, which is actually equal to ek. Change in ek. So yeah, my God. हो गया ये वाला question भी. Let's see कितनी देर की recording हुई because I want to keep the recordings very very short. So 25 minutes, a little more because I just want to keep it short bursts होने चाहिए rather than कि मैं एक साथ ही सारा करूं which will take a lot of time. Anyways, ये वाला question कर लेते हैं and that would be it. This is going to be the last question of the day. I'll keep the recordings very, very short and sweet so that you can follow it. Okay, guys. So, state the law of conservation of momentum. So, momentum before an event is equal to total momentum. In fact, event is equal to total momentum after an event. Could be an explosion, could be a collision in a closed, isolated system. Isolated system. No external force. No external resultant force. Okay, next step. Two particles A and B collide elastically. Okay, that is okay. As illustrated in figure 5.1, we can see that B is at rest and a particle collides with a speed of 500 meter per second. उसके बाद जो है, one of the particles actually move in this direction. एक इधर चला गया और एक जो है इस तरफ चला गया. Okay, so we have this. The initial velocity of A is actually 500 meter per second in the x direction and B is at rest. Oh, we already have this information. फिर ये कह रहा है कि हमारे पास कुछ angles बने. The mass of each particle is given to us as 1.67. This looks like a proton, basically. Explain what is meant by the particles colliding elastically. इसका मतलब है kinetic energy before and after collision must be the same. No loss in kinetic energy before and after collision. After collision. Calculate the total initial momentum of A and B. B has no momentum because B is stationary. A is moving. So total momentum, initial momentum must be equal to, direct बस कर ले इसको, तो ये हो जाएगा 500 multiplied by the mass, which is actually 1.67 into 10 raised to power minus 27 plus 0, because B is not moving. So this is going to be 500 multiplied by 1.67 into 10 raised to power minus 27. And this gives me a value of 8.35 into 10 raised to power minus 25 Newton seconds. So 8.35 into 10 raised to power minus 25 Newton seconds, or 8.4 भी लिख सकते हैं. Next step. State an expression in terms of m, VA, VB for the total momentum of A and B after the collision in the x direction. Okay, after के लिए लिखना है ना, expression बनानी है in terms of the x direction. So that we have to go back to the diagram. Let's just look at this thing. So afterwards हमारे पास होगा ये वाले का, हम लोग अभी इसको जो resolve करेंगे, we are going to be resolving these momentum in this direction. So that means पहले VA का tackle out कर लेते हैं. Let's just keep it. So this is going to be VA cos 60 degrees. And इसका भी कर लेते हैं VB का भी. So the VB cos 30 degrees. और इन दोनों को sum up करेंगे. So this would be VA cos 60 plus VB cos 30. I forgot. So V पता नहीं क्या था. So VA cos 60. The scrolling is very, very problematic. VB cos 60, 30 plus VB cos 30 degrees. In the y direction, अगर ऊपर वाला लेंगे तो let's just resolve it in the y direction. So y के लिए we are going to be focusing in the y direction. So I'm just going to be focusing on this line over here. So this is the line we are going to be resolving it in this direction. So therefore, पहला वाला जो हो जाएगा ये हो जाएगा VA sin 30 sin 60. So VA sin, this is actually VA sin 60. And नीचे वाला हो जाएगा VB sin 30. So this is going to be VB sin 30 degrees. In fact, अगर हम इनको करेंगे तो एक्सप्रेशन होनी चाहिए कि इन दोनों को सब्ट्रैक्ट करना पड़ेगा. जो बड़ा होगा वो ऊपर चला जाएगा, जो नीचे होगा, but that doesn't matter. So we'll just write it down in expression. In fact, ये दोनों बराबर ही होंगे. So this is going to be VA sin 60 degrees minus VB sin 30 degrees. That is going to be the expression. Calculate the magnitudes of velocity VA, VB after the collision. So after the collision का मतलब है we need to find it out. So in the x direction, हमारे पास पहले हम लोग अब हमें करना पड़ेगा. So we need to form an equation over here. We need to find VA, VB. So VA cos 60 plus VB cos 30 should be equal to the initial momentum, which was actually given to us as 8.35 into 10 raised to power minus 5. So 8.35 into 10 raised to power minus 5. यहाँ तक भी आ गए. And similarly, actually मैंने मास तो लगाया ही नहीं था. मास तो इसमें डाला ही नहीं है मैंने. Oh my god. M तो डाला ही नहीं था. दोनों के मास सेम है. So I just forgot about this altogether. So M and M. सही है. My god, momentum था. My mistake. I agree. I totally agree. Okay, सही है. Apparently वो वैसी कैलकुलेशन में कैंसिल आउट हो जाता है. लेकिन मैं एक काम कर रहा हूँ. I'll be very smart this time. So I'm just going to be writing this down as mass हर जगह same ही है, I guess. Both the particles are exactly the same mass. So M VA cos 60 plus M VB cos 30 should be equal to, in the x direction, जो initial momentum था वो भी लिख लेते हैं. M multiplied by the velocity was, I guess, 500. Check कर ले, just in case. Yep. So that is okay. 500. So across the board, mass gets cancelled out. I just want to verify if both the masses are the same. Two particles A and B collides. This is the velocity, the mass of each particle is given to us, which is okay. Mass overall cancels out. So ये वाली expression सही हो गई. Similarly, we can do the same for the other one. इसका मतलब है कि M VA sin 60 should be equal to M VB sin 30. दोनों बराबर ही थे. माइनस था तो उस साइड पे गया तो actually this should have been equal to 0, but I'm not going to mention that because it's just an expression. So at the end of the day, MM again cancels out. And we just need to make a substitution over here. We need to find both the values. So let's just make this substitute. VA को substitute कर रहे हैं. So this is going to be VB cos, okay, VB sin 30 multiplied by cos 60 divided by sin 60. I hope I haven't made any mistake. I'll verify it afterwards. Plus VB cos 30 is equal to 500. So we can easily find VB over here. So let me just check if I've done it correctly. VA को subject बनाया मैंने second equation में. If I made the VA the subject, so it becomes VB sine 30 over sine 60, which is correct. Similarly, cos 60, तो ये सब सही है. And similarly, this is okay, सही है. Okay. So let's just do the calculation. So sine 30 multiplied by sine 60 divided by sine, okay, cos 60 tha, sorry, cos 60 divided by sine 60 bracket closed plus cos 30. So VB की वैल्यू आ रही है हमारे पास VB 2 under root 3 divided by 3 is equal to 500. So 500 divided by answer gives us a value of VB as 433 meter per second. This is done. After the collision, VB की value तो आ गई 433. So इसको 430 भी लिख सकते हैं. Actually, I'm just going to write it down 430. So VA के लिए we can just input the value in V second equation. So VA is actually equal to 433 multiplied by sine 30 divided by sine 60. So VA भी आ जाएगा हमारे पास. Whatever value that I've got in the calculator, I'm just going to proceed that. Multiplied by sine 30. I hope this is correct. Yep. Divided by sine 60. Yep, 250. So that does it. I guess that's it for today, guys. Work hard. You still have time. जितने questions करोगे उतना अच्छा होगा. नहीं करोगे, then be ready for a retake, which I do not encourage. Get an A, guys. Get an A. Anyways, guys, take care. अपना बहुत बहुत ख्याल रखो. अल्लाह हाफिज़. This is the Eid third day of the Eid. So I've been working on A2 videos for the past 2 days. Today is the third day, and so that is it. This is what I am. Anyways, guys, take care. अपना बहुत बहुत ख्याल रखो. अल्लाह हाफिज़.